we have equation x in exponent n is equal with n in exponent minus x. So let me rewrite again this equation. Okay, so this equation is in this form: x in exponent n is equal with n in exponent minus x. Before I go any further, let me do some restriction. Let n is element of integer. Can be any number, but let me say this is an integer for this case. And let me write some criteria for the Lambert W function. Some criteria are in this way. So w x in x is equal with x. So I need this criteria. And then the other is a w of x in exponent w of x is equal with x. And so this was equal with x. I forgot to write. And from the second criteria, we can find if we wanted to solve in terms of EW of x, we have EW of x is going to be equal with x divided by W of x. So I needed these three criteria in order to solve the Lambert equation. And now let me take here ln both sides. If we are taking ln both sides, we have ln of x in exponent n is equal with ln of n in exponent minus x. And according to the properties of the ln, the logarithms, we can put this exponents in the front here, and the same thing in the other side, we can put the exponent in the front. And now we have this form: n times ln of x is equal with minus x times ln of n. And now I'm going both sides to divide by n and minus x. So I want to put the x's in one side and the n numerical values in the other side. So I want to divide both of them by n and minus x. If we are dividing both sides by n and minus x, we get ln x. So ln x is going to be divided by minus x is equal with ln of n divided by n. That's what we have. But now this I want to put in a numerator, and from this implies we have a minus x in exponent minus 1 times ln x is equal with ln of n divided by n. And another criteria here that I want to write is, for example, if I have x in exponent minus 1, I can write as e in exponent ln x minus 1, because x minus 1 gets in the front end, e ln is 1 times x minus 1 is x minus 1. So this criteria we can apply here, and instead of x minus 1, I'm going to apply this e in ln x minus 1. So because I want to get in the form what we have Lambert form. So now this equation is going to get the following form: is a minus ln x is times e in exponent ln x minus 1. But this minus 1 I want to make the same. This one x minus 1, so I want to make ln x minus 1, and this one to make the same quantities. But first of all, let me rewrite this equation, and this is equal with the ln of n divided by n. And to make this minus, I'm going to put here is in the power, because here is invisible 1, and this implies ln of x minus 1 times e in ln x minus 1 is equal with ln of n divided by n. So we are here now, so I can, let me go a little bit down to make some space. And since I am in this position here, I'm going to take a Lambert form both sides. W with a Lambert form with a w, I'm going to multiply both sides, and we have here w of ln x minus 1 in exponent e ln x minus 1 is equal with w of ln of n divided by n. And now this criteria here, we got now we can use this Lambert criteria, this one here, this form. So, and we can write is equal with the x, but instead here of the x, this one can be equal with the ln x in exponent minus 1. So this one can be ln x minus 1 is equal with the w ln of n divided, so let me write this ln, so that looks like ln divided by n. And now this one here I'm taking a ln, I want to lnize both sides, and from this one we can write e in a ln x minus 1 is equal with a e in the exponent w ln n, so let me write this better, divided by n. And this x minus 1, according to the properties of the logs, exponential function goes in the front here, and e in ln 1 is 1, so I can write that x in exponent minus 1 is equal with the e in a w ln of n, and everything here divided by n. So let me go a little bit further, and this implies x in minus 1 I can write as the 1 over x is equal with the e in a w ln of n divided by n. And now I want this to solve for x. If I'm solving for x, or if I'm taking the shortcut, I'm exchanging the position of these two quantities between each other, and the x is equal, so I'm taking a shortcut, 1 divided by e in a w ln n divided by n. So I didn't write very well here because I was trying to squeeze. And let me go a little bit further here. Let me take now this criteria here. E in w f of x is equal with x wx. So if I'm taking this criteria, e in a w x is equal with x divided by w of x. So this criteria, because we cannot see from there, but just let me see is right. This is the right one. And if I'm plugging here, then I'm going to get this form. Here is 1, and instead of e w ln n divided by n, I can write ln n, ln of n divided by n. So still I need to make a more room, and is divided everything by w of ln n divided by n, in w ln of n divided by n. And if I'm taking here a double fraction, for example here divided by 1, outside with the outside, if I am multiplying, and inside with the inside, so x is going to be equal with the w ln of n divided by n, and here is everything divided by ln of n divided by n. But still again this one here, if I divide everything here by 1, and 1 times n is n, and if I'm taking shortcut, this n can go here, and the final answer is x is equal with the w ln of n divided by n time n, and everything here is divided by ln of n. Or you can leave this result, or this one here, and if you wanted to find the numerical value for the x, then we can use alpha Wolfram calculator, and you can give us some numbers, the integers n, and then you can evaluate. But I'm leaving it here as a general form.